So we're going to go ahead and get started here today. So things we're going to talk about today is we're going to go over the quiz that we took on Thursday, talk about random numbers again, and cover all of the miscellaneous content from Chapter 2 that we haven't covered in any other topics. So before we get started, any questions on anything that's happening now? You should see everything that you've done in this class graded on D2L. If you have any questions about any of that stuff, feel free to send me an email, stay after class. Any of those things. So again, any questions? Huh? Um, I guess I am. I guess I skipped day 4 for some reason. I thought I had already done that. So yeah, that'll still be graded. But I did grade 6 and everything else. So. Alright, so gonna go over the quiz really quick. So you should be able to go in. I'm going to go ahead and allow you to look at what your answers were and what the correct answers were. Unfortunately, that's a little bit harder to do than it actually is to say. I think it's this one. Yes. Yes. Yes, yes. Okay. So now you should be able to go in and see the correct answers if you want to, but I'll still go through it real quick in class here to see if you have any questions. Again, by all means, if you think I graded something incorrectly or unfairly, just let me know and we can talk about it more. So when you're looking at your quiz, do note that all the questions are in random order. So my order will be different than yours, but we'll just go through and talk about it. So 3 variables that we've talked about in class, we've talked about integer, or you could have said int, talked about decimal, or float, or double. We've talked about char, or character. So that would have been the correct answer for that. And just yell at me if you want me to stop and talk about something any more along the way. So in the following code here, the only error in this code is there is a semicolon missing at the end of this line. So instead of saying this, we should have said this. If you said something like missing semicolon or anything along those lines, I would have given you points for that. A couple of you said that this was the incorrect part, this int main void. That's not actually incorrect, it's just a slightly different coding style. Basically, you can say with brackets, or I should say parentheses, and provide nothing inside of there, or say void. Saying nothing or saying void is exactly the same thing, because it's void is just void of anything. Just kind of an indicator that main doesn't take any parameters. We'll talk more about why we would say void in our brackets later, or parentheses. But that was the main thing. Like if you put this through a compiler, it would tell you it's missing a semicolon somewhere, and that's the main thing that's wrong with this code. So given this variable, write a printf statement which outputs the variable value. So we just say printf %i new line my int. Now something I'll probably talk about today is why I use %i and why you can also use %d. We'll come back to that later. If you use %d instead, I also should have given you full credit. So we're going to print my float to 2 decimals of precision, so I need to say printf. We use the %f, and then my float. So that's going to print it to 6 decimals of precision by default. So again, in order to change our levels of precision, we need to put a number in between the % and the f. So we say decimal 2, and that will print my float with 2 decimal places. So this should print out 10.99 if we were to run this code. So given this variable, my int, again, write a scanf to read in from the user. So scanf, %i, no spaces, new lines, anything like that inside that. We're just reading in a single number. Then we say an ampersand, my int. Remember that we need the ampersand on the variable name when we're reading into scanf. That's important. If you did something and put a new line inside of here, I might have given you points. I don't know. I don't really know offhand. So write a GCC command to compile a program. So let's say you said nano program.c and you had that program. The next thing you would do in order to compile that program would be to say GCC and say program.c. And that's all you would need. This is the only thing I would have expected you to put. You could also renamed the output. Instead of saying a.out, it would have outputted to program if you so choose. So the basics of what a compiler does. So remember that when we're typing in our C code, we're typing it in a way that we can read it. So basically what I wanted you to talk about was a compiler takes the code that we can read, the human readable code, and converts it into code that the machine can read. There's a better definition in here somewhere. I think. Let me see if I can find it. I don't remember exactly which section it was in, but yeah, I don't care right now. But there's the good, really good definition. But again, simply what I wanted you to say is it takes our human readable code and translates it into machine code. That's all the compiler really does. Everything else, if it's checking for errors, doing anything like that, is completely secondary to its actual task of taking the human readable code and translating it to machine code. So for this one, remember that when we are using printf, we can specify a variable or a literal value. So in this example, we're specifying a literal value. So we're going to take this 10 and it's going to replace this %i, and the 11 is going to replace the %i, and same with the 12. So this would output 10, 11, 12. So note, unless we actually specify a space here, so let's say this is our, we're working on this one right here, we have 50. So if we were to, I'll copy it down here. If we were to do this, that would print out 50, 50, 50. Now if we wanted a space after each 50, we'd have to put a space inside our format string. So if we did %i, or whatever other format identifier we wanted, and we said space, then there'd be a space separating each of these numbers, okay? Now if we wanted them printed on their own lines, we, instead of putting a space, we put a new line. All right. It's important to remember that if we don't put anything else inside our format string, the printing will continue on immediately after the output. So let's say we just execute line 11, so we're going to output 50, and there's no other spaces anywhere inside this format string. So when we continue on to number 12, we're immediately going to print 50 and 50 again. So a lot of you did do this. You put something like 10, 11, and 12. And I let that slide for right now, but just keep in mind in the future, you do need to be wary of whether or not there's spaces, other characters around your format string, inside of your format string. And then finally, how do we enable the printing of output? This is straight from the text. So we say include stdio.h. And that's how we both enable output and enable input. So any questions about the quiz right now? Yep.
I do have one question. It's just me. Do you want me to talk to you after the problem that you're creating?
Yeah, sure. If it's a specific question.
Yeah.
Okay, yeah, definitely talk to me after. All right, so on to reviewing random numbers. Where's my term? Right here. So this is essentially what we did on Thursday. we talk about random numbers. So remember that when we use a statement like srand and then times 0, we're going to seed the random number generator at the integer describing the current time. Remember this, the result that's returned by times 0 is an integer describing the current time in the number of seconds. So I did the example on Thursday that if we ran a program that just printed the result of this expression right here, it would show an integer that was incremented 1 every single second. So again, the reason we're seeding our random number generator to the time is if we seed it to a set value, remember, I'll just do this example again. I gotta redo all my printfs here. Give me a second. Remember that if we seed it to a set time, we'll always generate the same sequence of random numbers. But if we seed it to a number that's always changing, we'll always get a different sequence of random numbers. Run it once, run it again, and we get different numbers every single time. So again, for debug purposes, what we'd want to do is maybe comment that out. Remember that we can comment out a single line of code by saying 2 forward slashes. So comment out that srand to start off with, and maybe put a set number in there. So maybe we're always going to start our random number sequence with the seed value of 100. So that's that. So when we're running, remember that this is what we consider an expression. So we get the result from this rand. I'll just go through and show you what that would look like again. So I'm going to print out what the result from rand would look like. And remember, it's going to return essentially as big a number as it possibly can. Now, in order to manipulate rand in a way that we want, we need to say rand mod 100 or so. And that will allow us to generate numbers between 0 and 99. So every time we run this program, it's going to generate a number somewhere between 0 and 99. So remember that what happens when we say mod is we get the result of the remainder from the division operation. So when we take, well, let's do this. We'll say res. We'll store the result from our random column right here. And then what we'll do is we'll print off that quick. And then we'll print off the number that was generated, mod 100. So you can see that there was a big, huge number generated, but when we're saying, at least for 100, what we're saying is we're going to divide this entire number by 100, and whatever the remainder is going to be the number generated. So we can see, if we run this a couple times, there's a relationship that we can see here when we're running it mod 100. So if we're dividing by 100, we're just going to always get the last 2 digits. If our range is a little bit different, we're still going to get the same results when we take the result from the rand function and get the remainder from the division operation. We're always going to get, let's say we have mod 10, we're always going to get 0 through 9, or 15, we're always going to get 0 through 14. This is kind of just trying to help you understand what's actually happening here. So again, we take this big number, we divide it by 100, and we get 35. That's the remainder from our division operation. And so on and so forth for the rest of the examples. And you can see the relationship between the result from the random number, the raw result from the rand function. So the result from this is this big number again, and the result after the mod is this. So again, in order to control what we're doing, so again, we say rand, and then it will be 0 to whatever we specify here minus 1. So again, when we say 100, that's going to be 0 through 99. If we specify 50, That will be 0 through 49. Now, something that we can do, we can adjust what our base is. So let's say we wanted to generate, let's say we wanted to generate 10 through 20. So to start off with, we need to generate 0 through 10. So if we want to generate 0 through 10, we need to do rand mod 11. So that will generate it'll generate a number somewhere between 0 and 10, because remember, it's always going to be 1 less than what we specify here. So we have a range between 0 and 10. Now, in order to get that to be between 20 and 30, what we need to do is add 10 to this result. So if we add 10 to that, so now instead of starting at 0, we're going to, sorry, I'm off by 1. I need to say plus 20. So now instead of starting at 0, we're going to start at 20. And now instead of finishing at 10, we're going to finish at 30. Because we added 20 to each of these results. So we just added 20 to 0 to get to our new base of 20, and we added 20 to 10 to get to our new upper bound of 30. So go again. We can see that when we run this, run a bunch of times, you can see that our numbers are now between 20 and 30. So we can do this any other way we wanted to. We can specify any other number base. So let's say we wanted to generate, let's say I wanted to generate 100 to 200. What would I put here? So I have my rand. I need a number right here. So right in that blank, and then I need a number right here. So fill in those 2 blanks for me. So we want to go from, 100 to 200. Not quite, I don't think. Yep, there you go. I think that's right. So when we do 101, what that's going to do is generate numbers between 0 and 100. I remember if we said 100, we would only get numbers from 0 to 99. So then we're also going to say 100, you said? Plus 100. Okay. Remember, if we just have rand mod 101, that's going to be 0, or I should say that's going to result in 0 through 100. And then if we have rand mod 101 plus 100, that's going to take this, and it's going to shift it all up 100. So now instead of saying 0 through 100, we'd say 100 through 200. So we'll just go through, do a couple of, we'll run it a couple times here. I was making some variables, so I'll just go ahead and delete that. So 140, 180. So we can see that those numbers look like they're probably going to be all within that range. Just again, remember that the number specified here is not the upper limit. It's the upper limit plus 1. So our upper limit for this expression right here, the maximum number generated from this, again, is 100. And the lower bound, the lower limit, the smallest number generated would be 0 from this part right here, just this part. That's not my button. That's my button. Okay, just this part right here. The entire thing is this. All right. So that's how you would generate other random number ranges other than ranges that started with 0. You need to add to this base expression. You could also subtract if you wanted to. So let's say we wanted negative numbers. This is going to give us something a little bit strange, I think, if I know what I'm doing. But it might be perfectly fine too. So instead of saying positive 0 through 100, we say negative 0 through 100. Or not negative 0. 0 through negative 100. Slightly different. I don't want to get into the whole is 0 negative thing. But so yeah, you can modify those random number ranges as much as you so choose. So that's it for random numbers, I think. That's as much as we're pretty much going to cover in random numbers. We'll certainly continue to use random numbers throughout the rest of this course and any other CS courses that you would be in at DSU. So any questions about random numbers right now? Yep.
Could you do it the way, like, so instead of 101, could you do it like 200 minus 100 plus 1 in there?
Okay, tell me, so you want, here, I'll just make another one. So you have, so what should I put here?
So make another bracket. Oh,
Should I put parentheses around this whole thing?
yes.
Okay.
Then make another one inside of it. Well, like, don't close it, but make another.
Like that?
Yep. And then do 200 minus 100 plus 1. And then plus 100 at the end.
Like that? Or inside the bracket?
Inside the bracket.
Or parentheses, sorry.
No, sorry, outside of it. No.
Outside of it?
Yeah, outside of it.
So you're talking like that.
Yes.
That's what you're thinking. Okay, well, let's take this. So these, I mean, this is going to resolve to the exact same thing, realistically. So, I mean, you take 200 minus 100 and get to 100, and then add 1 in here, 101.
I was just making sure that was the way C book.
Yeah, they're kind of, what they're trying to do is kind of show you the offset, show you why they're being calculated, because this is, it's just kind of showing you how it's calculated.
Okay.
They're just trying to, because when you see 101 here, you're not exactly sure what that means. Maybe this is more expressive, I guess. I don't know. I don't really have a solid explanation. But yeah, obviously, like, completely valid too. Eventually, they'll probably start using the shorthand notation that I'd use, but just when they're introducing the topic, that's what they're going to use. So that's that again. So what we're going to do now is there's a couple other things in Chapter 2 that I wanted to go over quick. Just a reminder that you should have read Chapter 2 by today. Let's see here. So only 56% completion right now in Chapter 2. So I'll probably grade, or I'll pull in the grades for that sometime tonight. So if you haven't completed that yet, I'd highly suggest going through that. I did get some questions on some of the book examples or challenge activities. So as I'm going through, feel free to stop me if you want me to look at any of the challenge activities or any of the other things inside of each chapter, okay? So just remember when you're going through, if there's a section marked optional, you don't have to do it. So talked about variables already, not much here I don't think. Assignments. So just remember variable name on the left, expression on the right, and the expression can be any literal other variable name, function, or operator. We talked about operators being things like plus, minus, times, divide, and we have mod now too as well. So when we're naming variables in C, a couple of things to remember is that your variables can only start with, I don't like that view actually. So your variables can only start with a underscore or a sequence of letters. So let's say I had something like this. I had int a. That's perfectly fine. It starts with a letter. I could have like A100 or something like that. That's also valid. What I couldn't do is start my variable name with a number. So I couldn't have 10 dog or something. I have to have a letter or an underscore to start off the variable name. We also can't do things like put punctuation inside of our variable name, so I can't like have like D?G. That's not a valid identifier. I'd have to, again, only use letters, numbers, and only starting with letters or an underscore. So that's kind of important. So there's also things called reserved words in C. So a reserved word would be something like our data type saying int. So I couldn't say something like int because the name int is already used somewhere else in the language to describe something. This would be kind of redefining what int means. So again, whenever we see int, we know that's a data type, and we can't redeclare that. Same as we can't do something like int. I don't think we can do this. Maybe we can do this. I don't think we can, though. We can't do something like int printf, because this name is already being used for our printf function somewhere else in our code. So we can't reuse things that have already been used somewhere else. So that's that. The one thing that's interesting here is a great way to invert a variable. So let's say you have a positive variable and you want to make it negative. You can just put a negative sign out in front of it, and that will negate your variable. So if it's negative, it'll make it positive. If it's positive, it'll make it negative. So that's one thing to take out of this page. Yeah. So remember we talked about constant variables on Thursday. So when we have a variable that isn't going to change, it's always going to be the same number. We want to make it constant. We want to make its name all capitalized. So we know that it's a constant. So we just, instead of saying double, we would say constant double. And that's that. So here's something new that we're going to do today. We're going to talk about some math functions that we haven't talked about before. So let's do this. So in order to, where's my terminal? Over here. So we have another include that we need to use and able to enable our math functions. We need to say include math.h. So let's make a little program that's going to calculate the square root of a number. So I'll say double A, and then we will read in to that variable. Remember that we need to use %lf when we're reading into a double. So what this program will do is just calculate the square root. So one thing that we need to do is when we are compiling a program that uses the math header, we need to say -lm. So we need to say -lm like that. Otherwise it'll say undefined reference to sqrt. So let's put in 16 and we'll get our square root to be 4. So if we wanted to calculate the square root, we can just include this math.h and then say sqrt, and then inside the parenthesis provide the value that we want these square roots to be taken of, and then it will perform that operation and store the result in our variable on the left-hand side here. So we can also substitute that with an expression if we wanted to. So instead of actually typing in a value, we could put a literal number. Remember? So that will net the same result. So that's one of the math functions that we can use. And I think there was a couple other ones. Yep, so we do have a bunch of other ones here. There's a table containing a bunch of the math functions that we can use down here. So the other one that I want to talk about is power, because this one is typically used. So let's say we wanted to, let's read in two numbers. We'll read in double A and double B. So LF, LF, A, B. So what we're going to do is take A to the bth power. So what we're going to say is res equals pow A comma B. So we provide the base as the first argument, and then the power as the second argument. So we're going to also write a pretty complicated printf here. So we're going to say, well, it's not pretty complicated. It's just a little more complicated than what we're used to. So we're going to say %f to the %f power is %f. So the first thing we're going to do is put A here. So A is going to be the value stored in A, the value read into A in the scanf is going to be printed here. And then the value B, stored in B, will be printed here, and the value in res will be printed here. So let's say we typed in 10 to the 10th power. What's going to happen is 10 is going to be printed here, 10 is going to be printed here, and the result's going to be printed here. So remember that we are printing using floating point numbers right now, and what that means is we'll print to 6 decimals of precision. So let's just change that, print to 2, so it's a little bit more manageable. So remember to do that. We put a 0.2 between our % and our f. So the LF is only required when we are scanning. It's actually allowed to just say %f when we're printing most of the time. There's some edge cases that we need to worry about, but sure, we'll change that. So instead of saying an ampersand, I said %, so I need to go back and I need to change that to be in an ampersand. So we'll say 10 to the 10. And that didn't work at all. I did something completely wrong. I might have. I don't know what I'm doing wrong right here. Did you have some? Did you think of something? Anybody? I don't know. This is. Okay, I'm just going to change my numbers and see what happens. Okay, that worked. That worked too. I think it's something to do with its reading in. What? Okay, I'm just really bad at math then. Sorry guys, that's right. Yeah. Okay. Continuing on. Didn't look right. There's too many zeros there for my taste for some reason. Okay. Yeah, if I'm off, just let me know, because sometimes I'm just not on. But anyway, you can use all of these functions to do any of these other math operations. So a couple other ones that are important. Obviously, all your trigonometry. functions, your cosine, sine, tangent, if you were working on any programs that required any of those operations. So for more information about those, you can just look around the internet if you so choose. So we talked about this a little bit earlier, is type conversions. Let's see if there's any more here. So just remember, if we are working on integer data and we're trying to store it in a double type, we need to cast it to a double. So let's say we have this. So remember, if we're doing something like division, and we have, let's change this to 9. We have something like this. That's going to truncate the decimal. So again, if we need to do an operation and store it in a double, we need to make sure that one side says double, like that, or is typecasted to double. So now we'll get the correct result when we are doing our division. So by default, what we can do, if we take and we try and store an integer in a, let's say one type and another type, if it's coming from an integer to a double, it'll just extend it out. There won't be, it's just implicit. But remember, if, again, we're going from a double, so 10.5 to an integer, and we change this around, say C equals A, variable. We want to say this the other way around, sorry. A equals C, if we're taking from a decimal into an integer. Remember, that's going to drop the decimal component of that, and we're just going to be left with 10. So remember, we truncate the decimal when converting to double to integer. So if we need to convert from different types, it's really important to do it in division, but there are a couple other things that you should look at in here that are kind of important. So on to characters. So remember that we can read in or print out characters by saying %C. But some things later on here. So it's worth noting that characters are actually just numbers in C. So for every character that you can type in the keyboard, it's associated with a number. So let's do this. I'll clear everything out here. We'll read in a single character from the keyboard and store it in C. And then we'll write a printf to print it out. Of course, I messed this up. I put a %sign instead of an ampersand. So you typed A. So what we can also do, we can actually print a character as an integer. So again, for every character that we can type on the keyboard, there is a number that describes it. So let's say we type A, it has a value of 97. Let's say we type capital A, it has a value of 65. So as it turns out, so for all lowercase letters starting at A, the base is 97, and the maximum value is 122 for Z. So if we were to type b, it would have a value of 98. Remember that lowercase a had a value of 97, and then increment 1 to get to b, increment another 1 to get to c. So if we type c, that would print out 99. If we printed d, or type d, I should say, that would print 100. So we range from, with lowercase a to lowercase a to lowercase z, we range from 97 to 122. So for uppercase a starts at 65 and uppercase z ends at 90. So that's what this table is talking about. So you can look at this table to see the character encodings in ASCII. So what that means, so when we type A, remember that the decimal value is 65, and then when we type capital Z, the decimal value is 90. So again, for every character that you see here, there is a numeric value associated with it. So let's say we typed the less than sign, so it has a value of 60. So if we went over this table, we looked at 60, we'd see that there is the less than sign. So this is kind of important, so let's look at a couple of things that are new here. So typically what we've said is we can only print with the same format identifier as is value in here. So what printf does when it sees this %c is it goes to a table just like this, and it finds the value that's stored inside c, and it replaces that value with the associated letter. So let's change this around a little bit. So we can also read in a numeric value into c. So all we're going to do is that's fine for right now. That should work. It's probably actually gonna be broken. Whatever. So let's say we type in, hopefully this will work. So we type in 65. So it tells us that we typed in a value of A because we read that 65 into C. Now we can do that. Right now it's going to warn us. We'll talk about that warning. There's the material that covers why this is a warning is actually in the next section in the book. But essentially we can read numeric values into characters. And whenever we use %c, it's just going to either read a literal character value. So if we type A, it's going to get the value that is associated with A and store it in that variable that we're reading into. Or if we're printing it out, it's going to take the value, store it in the variable, find the letter associated with that value, and print out that letter. So just remember that when we use something like char, that's just shorthand for a variable that can store a character, but we can also store numeric values in it. So any questions about ASCII formatting right now? Okay. So this is where we get into this a little bit more. So talking about numeric data types. Now this isn't terribly important that you understand this very well right now, but just keep this in mind. So when we say char, we can store numbers from -128 to +128 in it. So there's a bunch of other things that we haven't talked about. We haven't talked about short, haven't talked about long, haven't talked about long, anything like that. Those are for if we need to store really, really, really big numbers in. Right now, all we're going to need to use probably is just int and just char. So typically what we can do is store character values into a character, or a char, or we can store integer values into an int. But we don't necessarily have to do that. Let's say we had an integer. This is going to honestly be really confusing, but I'm going to talk about it anyway because it's kind of interesting. So let's say instead of having a char c, we had an int c. So we can actually store numeric or character values into that integer. 65 for a. So the only difference is the amount of memory that those two variable types take up. So when we have a char, that's only going to take up 8 bits of memory. But when we have an int, it's going to take up 32 bits of memory. And since, if we go back here to characters, So since our values are only ever going to be from, let's say, 32 up to 126, that's the only possible range for a character at this point. There's other encodings that you might think about later. Since that's the only possible range from 32 up until 126, then we don't need a variable bigger than between negative 128 and 127 to store anything in. So that's why we use char or char, however you want to say it, to typically store a character value, because we don't need a value bigger than that. The reason we use integer, going back over to this page, is if our value is bigger than this range. Okay, so let's say we have a really big number, let's 2 million, or what is this, 2 billion. But let's say we want to store 2 billion inside this. So we could do that by storing inside an int. But if we were to use an int to store every single character, then we'd just be wasting memory. Since a character only needs 8 bits, we'd be essentially just throwing away 24 bits every single time. But just keep that in mind, that we can use different data types for different sizes. But if we use different data types like long, then there's different format identifiers and format strings that we need to use for printf and scanf. So just keep in mind that we can change the supported number range. So this is important that you remember this, the supported number range. Just generally speaking, what you can store inside a character and what you can store inside an integer. And there's some representation stuff that's not terribly important. So we've talked sufficiently about random numbers. They talk about it a little bit more here. Some examples. So these are all of the format identifiers that we can use. So those data types that were talked about on 2.12, so like long and things like that, you would, instead of just saying maybe %d or %i, you'd say %ld, and so on and so forth, going on down the list. I'm not going to talk about that right now. So, style guidelines. So just keep, I did mark this optional. We're not necessarily going to adhere specifically to this style, but what you should do is make sure that for every statement that you have, it should be on its own line. So in C, it's not actually required that statements are on their own line. You could put multiple statements on a single line like this. All that matters in C specifically is that each statement is separated by a semicolon. So these two are completely valid like this. But this is typically preferred because with one statement on one line, you can see what action is being taken every single line of your program. Generally speaking, when you're doing sets of operations, so if these two operations are related, you should keep them together without putting any new lines between those lines, and then only split them up if they are unrelated. So if there's two unrelated sections, if these are unrelated operations, then split them up to try and isolate what they're doing. But if they're related operations, they should generally be no new lines in between. So ideally, what we should see when we're writing our code is spaces in between our equal sign here, spaces in between a literal and an operator and a variable, so on and so forth. So this is packed really tightly together here. It's not necessarily as readable as this side, so just try and put spaces between operators, variables, and all the literal stuff. So this is covering some more syntax that we haven't really covered yet in this class. So we'll skip that for now. So generally speaking right now, when you're naming your variables, what you should do is you should say int and then follow this or not int. You should say your data type and then you should follow this camel case convention. So when we say camel case, we mean we say the first word and then the second word with the first letter uppercase. So let's say I had a variable that I wanted to call, let's say I wanted to call it total value. So if I wanted to give that variable a name, I'd say int total value. if I wanted to add more words onto that, I'd say like total value today, or things like that. So you start off with the first word, with the first letter being lowercase, and then every other word that you encounter after that, its first letter is uppercase. So that's generally what we're going to do. So and then remember, if we have a constant, we want it to be all uppercase, and then use the constant keyword. And that's that. So was there some questions on any of the activities in the text that anybody wanted me to talk about? All right. So where was I at here? Do I have anything else that I want to talk about? Talk about data types, talk about some math functions, talk about ASCII. So yeah, if you don't have any other questions, that's all I have for you today. You should expect on Thursday, we're going to start covering new material from Chapter 3. I probably won't make you read that until next Tuesday. So have Chapter 3 read and completed the activities by next Tuesday. Plan on a quiz and assignment assignment being given out on Thursday probably, and a quiz being given out on Tuesday or Thursday of next week, covering all the content from Chapter 2. So that's all I have for you today. If you have any questions, feel free to stick around.